Hi guys, so today we're going to be talking about conversions between moles and atoms, section 10.2 from your CK12 packet. Big numbers or little numbers. We deal with both in chemistry. We deal with very large numbers of atoms or very small numbers of grams. It just depends, right? Atoms we know are very, very small, so when it comes to moles or atoms of them, you can have a lot. Atoms, not moles. And then once you change those atoms to grams, and then you change, from atoms to moles to grams, you're going to get these very small numbers. So scientific notation, superscripts, and subscripts are a part of everyday life when it comes to chemistry. All right, so who's going to help me with the introduction?
Do you hate to type subscripts and superscripts even when they go with the same program have to click on an icon to get the superscript? And then remember, after you type in a word, Ariel has no, it did not know about move and just knew about numbers. I don't want those big numbers that requires a lot of superscripts that would be much more complicated and we would make for typing error.
Oh, I absolutely hate, especially when I'm making my PowerPoints and I'm transferring information from one document to another, and I have formulas and stuff like that, or big or small numbers, scientific notation. You got to turn on that superscript and then turn it off. It's a hassle, trust me. I do it every night. Every time that I'm doing a presentation and I see that there's a formula, I have to double check if there's a subscript or if there's a number in scientific notation and I know there's a superscript. I got to watch out for it because sometimes they come out as regular numbers and students get confused. So, yes, I especially know as a chemistry teacher, superscripts and subscripts, nah, especially when you're typing them. Okay, but either way, they are part of chemistry, so we have to deal with them and we have to know how to handle them when we're doing today's type of conversions. And today's type of conversions have to do with converting between moles and, in this case, the number of particles. Okay, do not get confused if they have, and if you look at this diagram, which is now complete. Yesterday, we only did one part of the diagram. Today, we're doing the other half. Don't get confused when it's talking in terms of particles, atoms, or molecules. It's the same thing. Okay. In terms of conversions, it's the same thing. It's just if you're dealing with the moles of an element, you're going to use the term atoms. If you're dealing with moles of a covalent compound like water, it's going to change to molecules. Or if you're dealing with moles of salt, which is ionic, you're going to deal in terms of particles. It just depends on what you're working with, okay? They can be interchangeable. All right? So don't get yourself confused with that. I got you, Arlette and Kevin. Kevin, not George. Okay, so it says here, using our unit conversion techniques, we can use the mole label to convert back and forth between the numbers of particles in the moles. Sample problem number 1. Remember, I told you, in order to get good at this, at these type of conversions, it's all practice, practice, practice. So we start off this lecture with a sample problem, converting number of particles to moles. And then you have example problem number 1. This element carbon exists in two primary forms, the graphite form and the diamond form, right? Everybody knows that diamonds are made of carbon. How many moles of carbon atoms is 4.72 times 10 to the 24 atoms of carbon? Okay. So remember, this is your problem, but before you do that, before you start looking and analyzing the diagram and figuring out, do I divide? Do I multiply? You need to figure out what you know and what you don't know. You know two things, okay? You know two things. You know the given information. They're giving you the number of atoms. of carbon. 4.72 times 10 to the 24th. When it comes to, you also have a second piece of information. When they talk over here in terms of dividing and multiplying, you have a number, 6.02 times 10 to the 23rd. Whose number is that, guys? Kind of rhymes with avocado. Do you remember his name? Avogadro, right? Avogadro's number. Avogadro's number is a conversion factor between moles and atoms or molecules or particles, whatever it is they're asking you for. So we're going to use Avogadro's number to do this conversion, okay? So you don't know the question. The question here is asking you to change your atoms to moles. Okay, I kind of cut it off with this picture. I should have moved it over a little bit, but I apologize. It's supposed to say moles, okay? Moles of carbon to be specific. So I'm going to go to Jamboard. Let me go into Jamboard, come back to the Google Meet so you can see. So here, and you can see it right here. Here is your unknown. This is your question. They want you to change 4.72 times 10 to the 24 atoms of carbon to moles of carbon. Okay, so we're going from atoms to moles. Atoms to moles. Everybody sees that? So if you look at the diagram and hers, it looks a little different compared to mine. It's the same thing, okay? In my version, I actually show you what to do, okay? Because my students, they get very confused. Sometimes, not all the time. So if you have atoms, molecules, that's supposed to be an E right here, or particles, and you're trying to change it to moles, we got to do the other half of our diagram and make sure that you're copying this down. All right. If you are in atoms going to moles, you are going to take your given atoms, molecules, or particles, and you're going to divide it by Avogadro's number. Okay. So I'm just going to put given atoms, and I'm going to put, remember, M is for molecules and P is for particles. And I'm going to divide it by Avogadro's number. Everybody knows Avogadro's number, right? 6.02 e to the 23. Same thing. 6.02 times 10 to the 23 is the same thing as 6.02 e to the 23. Don't get it confused. And if I'm going from moles, sorry, if I'm given moles, I will multiply by Avogadro's number. Okay? Now that we know the strategy, let's figure out what we need to do. Do we need to divide? Do we need to multiply? Do we need to divide? Do we need to multiply? Let's look at the question. It's asking us, and let me circle. It's asking me to start at atoms and change it to moles. You see that? What's my strategy? You're given atoms and you're going to moles. You're here. This is where you're starting with atoms. You need to go to moles. Which curve? Top or bottom? This is your starting point.
Divide.
Yes, ma'am. You're going to take the top curve, and the top curve says you're going to divide your given atoms by Avogadro's number. Very good. Okay. So I'm going to take 4.72 e to the 24th. And I'm going to put my unit, atoms of carbon, and I'm going to divide it by Avogadro's number. 6.02 e to the 23 atoms / mole. That's your unit when it comes to Avogadro's number. So atoms cancel with atoms. And what do you get? Now, when you're doing scientific notation, how many people, raise your hand if you have an Android phone? If you have an Android phone, raise your hand. What? Raise your hand. You see how I'm raising? You see how we're raising our hands, me and Irvin? Anybody else have an Android? Okay. Okay. So what you're going to do is if you have an Android, you can get a scientific calculator using an app called Wabbit MU. If you search it in the Android store, it should come up. It's a free scientific calculator, and you can use the E. The E is on there, and it'll make your life so much easier. For us iPhone users, we have to pay. And of course, I'm not going to pay. I don't want you to pay. So there's another way, and it's the way I'm going to show you on your iPhones, okay? How many of you have iPhones? A lot of you guys have iPhones? Okay, yeah, we have more people who have iPhones. Yeah, look at that. We got at least 3. Okay, I had some people come in just right now. Let me get their attendance. Irvin, Gabby, and Ephraim. Irvin, before I forget, guys, because then I'll forget and I won't give you credit. Gabby, and who was it? No, Ephraim was already here. Okay, I got you. Okay, so get your phone out, guys, your iPhones. And on the calculator, if you're downloading Wabbit, I can show you how to do it there too. So if you have your calculator, and if you can try it on your Android calculator, if it comes out like this, when you turn it to the side, even better. That way you can just do it on your Android calculator. So the first thing you're going to do is you're going to put 4.72. Everybody put 4.72. Oh, not 4.74. 4.72. Okay, right? You put 4.72. Now, do you see that double E next to the number 1? It's kind of a little blurry to see, but there's a double E next to the number 1. Click on it. And then you're going to put what comes after, which in this case is 24. You should see this, guys. You see that? Kind of already shows you that number in scientific notation. Okay, so now you're going to hit divide. And you're going to put Avogadro's number the way you just did it right now. Divide. And you're going to put 6.02 e to the 23. And then, of course, you're going to hit equals. Did you guys come up with this answer? There it is, 7.84. That's your answer, Yalexia. 7.84 moles of carbon. Done. And my students like this section better, mostly because you don't have to calculate anything. You don't have to go find the number of atoms, go to the periodic table, multiply, add them up like you have to do for yesterday's work, right? Molar mass is a little bit different. Anytime you're going from mass to moles, you're going to need molar mass and you're going to have to do extra work. But when you're going from moles to atoms, it's easy because all you got to do is use Avogadro's number. Thank God for Avogadro, right? Thank God. All right. So that's the answer for the first one. And you can see the answer right here. Oh, I guess I didn't put it. It's on Pear Deck. Let's go back to Pear Deck. The answer's here. 7.84, just like we got it. Everybody see it right here? 7.84 moles of carbon. Same thing that we got. The given number of carbon atoms was greater than that of Avogadro's, so the number of moles of carbon atoms is greater than 1 mole. Since Avogadro's number is a measured quantity with 3 sig figs, the result of the calculation is rounded to 3 sig figs. I'm not really concerned about sig figs, okay? So don't worry about that. I'm just happy if you understand what to do. All right, you got a question, and this is a Pear Deck question, so technically you're supposed to do it on your own. Find what they're giving you and figure out, am I going to multiply by Avogadro's number? Am I going to divide by Avogadro's number? And try it, okay? Try it out. So it says here, how many moles is 4.6 times 10 to the 24 sulfur atoms? So now they're giving you atoms again, and they're asking for moles, right? Everybody see that right here? You got sulfur atoms, and they want you to change it to moles. So you're in atoms going to moles, you will divide. And remember, your given goes first. Your given always goes first when you're dividing. Okay? So given divided by Avogadro's number. All right, so let's get your calculators. And of course, you know me, I'm going to do it with you, but you're going to show me your answer first. So remember, put it to the side. 4.6 E, which is right next to the number 1. And if you have that Wabbit on Android, the E is right above the 7. Okay, the E, I believe, is right above the 7, if I remember correctly. So E to the 24th divided by 6.02 E to the 23. I have a number that looks a lot like the number that we just got.
7.61.
Very good. Look at that. Excellent. 7.64. Why do I have such wonderful students? I'm so blessed. Did you know that? I am so blessed with wonderful students. All right. Great job. Great job. Any questions on that one? That one, those are easy, right? Because they're really straightforward. Okay, now we're going to throw a wrench into the mix. We're going to mix it up. We're going to make it a little tougher, okay? Suppose you wanted to know how many hydrogen atoms were in a mole of water molecules. So now they're talking in terms of hydrogen atoms in a mole of water, okay? And you have a visual right here. On the bottom, this is your water molecule. In red is your oxygen. In white is your hydrogens. So you can easily tell how many hydrogens are in this molecule. Well, there's 2, right? You can even look at the formula and you can see that there's 2 as our subscript after H. So there's 2 atoms of hydrogen in 1 molecule of water, right? Excuse me. How many atoms of hydrogen would there be in 2 water molecules? Kay, do you have a question? Because your hand's raised. Caitlin? Okay, there would be 2, right? So now instead of 1 molecule, you have 2 molecules, just like you see down here. How many hydrogens? Well, how many white atoms? 4, right? 2 times 2 is going to be 4. How about if you have a dozen molecules? So that dozen is 12. So if you have 12 atoms or 12 molecules and each molecule has 2, you multiply it and you get 24. 24 hydrogen atoms in a dozen water molecules. To get the answers 4 and 24, you had to multiply the given number of molecules by the 2 atoms of hydrogen per molecule. So to find the number of hydrogen atoms in a mole of water molecules, the problem could be solved using conversion factors. Okay, so right now we're starting with 1 mole of water. Everybody see that? 1 mole of water. They're asking me, I don't want atoms or molecules of water. I want atoms of hydrogen. 1 element in that molecule. 1. So the first thing you're going to do is you're going to change your moles to molecules using the diagram, right? You're going to use this diagram right here to change your moles to atoms, or in this case, molecules, right? Because it's a covalent compound. Right now you're here, they're asking you for molecules, you need to take the bottom curve. And the bottom curve says we multiply. Very good. And you can see it here. Look, this number's on top, right? There's always an imaginary 1 down here. If this number's on top and this number's on top, they multiply. That's what we said to do. That's what our strategy said to do. But once you're done with the strategy, now you're in molecules of the whole thing, of water, not of hydrogen. You're going to have to do another dimensional analysis. You're going to have to do one more conversion where that conversion says if you have one molecule of water, you're going to have 2 atoms of hydrogen. And you can see that here. Since molecules is on top, molecule needs to go on the bottom, and we're only talking about 1 of water. And inside this water, there's 2 hydrogens, right? So this is where this number comes from. This 2 that's in our subscript is the same 2 that I see here for atoms of hydrogen. And what's left to do if they're both on top? We multiply again. And you should end up with this answer. 1.2 times 10 to the 24 atoms. Okay, and if you don't understand, don't worry. We are going to do a sample problem of this. The first conversion factor converts from moles of particles to the number of particles. The second conversion factor reflects the number of atoms contained within each molecule. And of course, this just describes what you're seeing below, or actually on the left. It's talking about the molecules. All right, let's go to our sample problem. Let's try it out and see if we're able to understand what they're asking me for. All right. Sulfuric acid has a chemical formula of H2SO4. A certain quantity of sulfuric acid contains 4.89 times 10, to the 25 atoms of hydrogen. How many moles of sulfuric acid is in the sample? So right now, they're giving me oxygen, atoms. They want moles of a compound, sulfuric acid. Very similar to what they did here, except now, instead of starting with your compound, I'm starting with the element. So the first thing I need to do is I need to figure out how many of the element are in the compound. So right now, I'm trying to figure out how many oxygens are in the compound that they're asking me for. And in this case, they're asking me for, they're asking me for moles of the molecule H2SO4. Everybody see that right here? They're asking for you to change oxygen atoms into moles of this whole molecule. You see how it's backwards? So don't worry. Let's figure it out. So we're going to start with our given information, and we're going to do dimensional analysis because there's no shortcut for this. I have no shortcut for this. It's not a common question that I normally ask in class, but since it's being covered in Pear Deck and in the CK12 packet, we need to cover it as well. All right. So we're going to start by putting 4.89 e to the 25. Oh, I don't know what that was. Atoms of oxygen. And why is it over 1? To make it easier to figure out where atoms of oxygen need to go. Where do atoms of oxygen need to go if I need to cancel out? Where does the arrow point? Down, right? It's pointing to the bottom of the next line. So that's where I put my atoms of oxygen. But Irvin, Oscar, Yalexia, Jeremiah, Caitlin, How many oxygens do you see here in this compound? How many oxygens here in this compound? 4, right? Everybody sees that there's 4 of them in here? Yes. Okay, so now I'm going to change my 4 atoms of oxygen and I'm going to change it to the molecule. And that's in just one molecule of the compound H2SO4. Sorry for the ugly O. So atoms and oxygen cancel, right? Atoms and oxygens cancel. They're gone. Now, what do I have to do if I have a number on top and a number on bottom? Multiply or divide? Multiply or divide. What am I going to do if they're on opposite sides?
Multiply.
Try again. What's the opposite? Okay, Jeremiah, anytime they are side by side, they're both on top, you will multiply. Anytime they're on opposite sides, you will divide. Okay, just to make it clear. Okay, so we're going to our calculator. We're punching in the 4.89 e to the 25. Everybody put the 4.89 e to the 25? I hope so. Okay, and now we're going to divide that by 4. What'd you get? I got an answer, but I'm not going to show you until you show me that you've done it. Is there an E behind that number, Oscar? You must include it. 1.222, isn't it? E.
Miss, ¿cuál era el number ese lo?
The 4.89. Aquí está. Este número por este número. We're dividing. 4.89 E25 divided by 4. Isn't there a number after the E, Oscar? E25. You must include it. If there is an E at the back of your number, you must include it. The E and the 25. Okay? So now...
Number, pero el último number es un 4.
No. No, it should be 25. All we did is we just divided the 4.89 by 4. Okay? Be careful. Double check what you put in. Do it again if you can. Okay? So now we're in... Oops. I need my marker. Now we're in molecules of H2SO4. Now that I'm in molecules, I can change molecules to moles, right? Using the diagram. What am I going to do if I have molecules and I want to change it to moles? This is where I'm starting. I need to change it to moles. What's my strategy?
Divide.
Very good. We're going to divide. We're going to divide our number of molecules by Avogadro's number. Molecules will cancel with molecules. Let's punch it in and let's see what we get. 1.222 e to the 25 divided by 6.02 e to the 23. I got a number that's bigger than 10 but smaller than 30. What's your number? What do I get if I were to divide these two numbers? Caitlin, do you have a question? You have your hand up still. Or is that for my question about the iPhone thing?
No, miss.
Thank you. That's what I thought. Okay, what's your answer? What's your answer? Do you have an answer? Because I have an answer.
Wait, dividing which numbers?
We're doing we're doing the bottom. We're doing these right here. Okay. Since you came in late, you do you have an iPhone or do you have an Android, Irvin? Okay. There's this website or an app known as Wabbit MU that has a free scientific calculator that you can download for free that us iPhone users can't. They make us pay for it, and there's no way I'm going to make anybody pay for it. So I showed the iPhone users how to do it on their phone. But you can download that app and you can use it's a scientific calculator which makes all of this easier. So nombre, tú lo tienes hecha. Did anybody come up with an answer for this? What'd you guys get, Oscar? 1.22 e to the 25. You're dividing 1.22 e to the 25 by Avogadro's number. Nobody has posted an answer. I don't see anything in the chat. Yeah, Alexia, did you try it? Did you try doing this?
It said 0.22 E95.
No, it's a number. It's just a regular number. There it is, Oscar. Oh, yeah. But you have a.
But I put the point at the beginning.
Oh, but you put the E, right? So, yeah, it's the same number. It is the same number. It is. You're right. My bad. 20 point. If we round it correctly, isn't it 30 moles? If we round it correctly. Sorry, that one's such a mess. I should have probably done it over here. I left that slide blank so that we could do it over there, but I guess I forgot. My bad. Okay, let's continue. Let's finish up. Let's see if our answer is correct. 20.3. There it is. All right. We don't have time for the video. Let's just finish up. In summary, methods are described for conversions between moles, atoms, and molecules. You guys can go ahead and watch that video on your own if you really want to. If you don't worry about it. Review questions. What conversion factor would we need to convert moles of helium to atoms of helium? Number 2, I want to convert atoms to moles. My friend tells me to multiply the number of atoms by Avogadro's number. Is my friend correct? Number 3, why do we need to know the formula for a molecule in order to calculate the number of moles of one of the atoms? Number 4, how many atoms of fluorine are in 5.6 molecules, 5.6 times 10 to the 22 molecules of magnesium fluoride?